Environmental problems are of extreme importance and one of the major concerns in the 21st century. With the constant growth of the world's population and consequently its resources consumption, sustainable measures are necessary to protect planet Earth from collapsing. One of the main issues on this topic is the energy crisis. According to the United States Environmental Protection Agency, the production of electricity and heat accounts for 25% of the global greenhouse gas emissions. Another huge contributor to this issue is the industry, producing a fifth of the total emissions. This means that if the industry does not use energy as efficiently as possible, it wastes a costly resource, the production of which creates even more gas emissions. In 2021, global energy-related carbon emissions rose 6% to 36.3 billion tons, the highest level on record. Due to this critical picture, it is necessary to take advantage of the technological advances and make beneficial changes for the environment as well as for companies that can reduce costs and optimize their energy consumption.
One possible way of optimizing energy usage is identifying anomalies or deviations in the expected energy consumption data over time. That is where TSAF, the time series analysis and forecasting software from ICON Pro, comes in. With TSAF, it is possible to predict future energy consumption, identify anomalies and sudden irregularities in the data, and consequently expose flaws in production chains such that appropriate measures for energy optimization are taken. The Automotive Manufacturing Corporation, Opel, has recognized the need to optimize its energy consumption and joined the AI-Net ANIARA project in an effort to research and develop approaches to save energy and reduce costs. Currently, the solution Opel possesses deals with a single rule of trying to keep the energy consumption within a nominal threshold and thus is quite limiting for energy managers to draw definitive conclusions about what can be improved in their manufacturing processes. A significant improvement would be to compute various key performance indicators based on specific stages of production, thus identifying which part of the production chain introduces energy leakage. For example, in this case, we can see an energy leak in the powering up production phase. Until this final step can be reached, however, we first need to collect data, validate and clean it to ensure good quality data, which can be achieved by employing various plausibility checks set by expert energy managers. Then, we must automatically identify the production states from the incoming time series data and classify which periods are powering up, producing, powering down, in between shifts, and non-production. Talos can do all of this automatically. Talos is a software built on ICON Pro's TSAF for the ANIARA project, and it helps Opel identify imperfections in their energy usage. To allow energy managers to find abnormalities in their manufacturing processes, our partners from Fraunhofer IPT developed a Power BI dashboard showing quick and insightful analytics about the energy used based on results from Talos. For each measurement, you can see the percentage of data points that have passed a specific logical check. All data points that have violated a check are listed in this table. We can also see the points violating any check in the graph below as the red curve, whereas the blue points are the original data. Talos also finds the measurements that depend on one another, and by visualizing them for a specific week, we see how the energy measurements move together. ICON Pro Talos identifies anomalies if these similar features stop correlating with one another. As mentioned, ICON Pro Talos automatically labels specific production states, and the results can be seen here. Thanks to the Talos engine working in the background, we can then observe various statistics about how long a certain phase takes or how much energy it uses and decide whether that is unacceptable and an energy leak is present. The dashboard also permits us to compare the key performance indicators across multiple sites. Opel envisions that by 2030, once the development of a fully digital energy management platform is completed, Opel will observe a 3 to 5% reduction of energy consumption and CO2 emissions in their production chains. This also amounts to €2 million savings annually in total. Specifically, the energy optimization achieved with the activity state detection approach is expected to save €170,000 annually per plant.
In the remainder of the ANIARA project, we will seek to research anomaly detection occurring in the incoming data, benchmark and improve activity state detection, and deploy Talos and Power BI dashboards on the Opal IT infrastructure for it to be used by the energy managers. Lastly, work on the disaggregation use case to determine the status of equipment behind a meter reading without knowing them, as well as create new predictive maintenance use cases.